Welcome to this new lesson on addition or subtraction of matrices. And basically what we are going to cover today is just those two, the addition of matrices and subtraction of matrices. So we are going to get an overview of the two of them. What does it mean, or what conditions are normally there for you to say maybe in matrix A and matrix B, they can be added up or they can be subtracted. And then after that, we are going to have some examples to see how those can be done. All right, so we start with the addition of matrices. And we say that two matrices P and Q are conformable for addition if they have the same order. That is, the number of rows and the number of columns are the same. So here basically, matrix P should be of the same order as matrix Q in terms of the rows and the columns. So, and as we can see from here, we have matrix P plus matrix Q. So we have P11, P12, P13, P11, where this is the first element in the first row in the first column. P12 is the element in the first row, second column, all the way to P33 is in the third row, third column. Then we add Q's, I all the way to J. Now, if we add the two in addition, normally you take this P11 and the other element in the same position. So we have this one, the P11, it's the element in the first row, first column. So this one has to be added in the other element, in the other matrix, in the same position, the first row, first column. The same applies to the second, the P12 should be added to Q12, P13 should be added to Q13, and that's where we have the P11 plus Q11. Then we have P12 plus Q12, all the way to P33 should be added to Q33. And as you are going to see, these rules apply for both addition and subtraction. What changes is just the sign here. So here we have an addition. If we go to subtraction of matrices, we are going to have a negative sign, but the rest is just the same. So it's elements in the same positions. They go with each other, right? So let's look into an example. So we have example number 1. We have the first matrix added to the second matrix. The first element is 10, it has to be added to 4. So we have 10 plus 4, and then 9 has to be added to 2, 6 has to be added to 6, 6 again has to be added to 5, 8 has to be added to 7, 8 has to be added to 5, and 3 has to be added to 2, 2 has to be added to 1, and then 4 you add with 1. Just as simple as that. So in addition and subtraction, elements in different matrices, you either add or subtract based on their positions. So if it's in the first position, the first element in the first matrix should be go, or should be added, or maybe should be subtracted to the other element in the same position. And that's why we are talking of 10 plus 4. This is in the first, this is the first element in the first row, first column. It's the first element in the other matrix in the first row, in the first column. So you add the two, and the same applies to the others. When you do the addition, you're going to get 14, 11, 12, 11, 15, 13, 5, 3, and 5. Example number 2, where we have negatives. So we have a -1, 7, -6. So we have this basically the first matrix, and then we have the second matrix. The same rule applies. This element, the same position should go with this. This other one should go with the other one. That other one should go with 6. 15 should go with 8. -2 should go with 1, 9 should go with 19. Now remember, don't forget to consider these signs the way they are. So if we have a negative sign, please make sure it's there. And then, so it's a -1. We are talking of addition, and then a -5. So you pair them as per their positions, the way I've paired, the way they are here with the addition sign. And then we have some signs down here just for you to remember that whenever we have a negative multiplied by a negative, you should end up with a positive sign. If you have a negative sign multiplied by a positive sign, you get a negative sign. If you have a positive multiplied by a negative, you get a negative. And whenever you have a positive multiplied by a positive, you get a positive. So as you're going to see, this one will be very useful in doing this calculation. So for instance, here we have a -1 plus -5. So you see here we have these two signs next to each other. So this is just the same as plus times minus. So you should get a negative. It's a minus. Plus, where is it? Plus times minus, you get a negative sign. So this is the same as -1 minus 5. And then you get a -6. Then this one is easy, 29. Then we have a -6 plus 6, that's 0. Yeah, you just do the calculations and you're supposed to get the answer as this one. If you have, maybe if we check this one, 10 plus -20, plus times minus is a minus. So at the end, you're going to have 10 minus 20, and you get a -20. All right, so let's move to subtraction of matrices. And this is no difference with addition. The only difference is a negative sign. So whenever you have two matrices, P and Q, they are said to be conformable for subtraction if they have the same order. That is, the number of rows and the number of columns are the same. They are of the same order. So this is just the same as what we've seen with addition of matrices. The first element here is the first element here, and then you subtract the 2. You have the P22, you subtract with Q22, yeah. So just like that. And let's look into an example. So this example is exactly what we had with addition of matrices. The only difference is the negative sign. So you're going to have 10 minus 4, 9 minus 2, 6 minus 6, all the way to the last row, 3 minus 2, 2 minus 1, and then 4 minus 1. When you do the subtraction, you're supposed to get that answer. Right, example number 2, still the same example that we had on that section of addition of matrices. The only difference is the negative sign. But of course, you must arrive at different answers because the signs are different. So when you pair every element with its the other element from the other matrix, and then you subtract, also bear in mind these signs. Whenever you have a negative multiplied by a negative, you should get a positive sign. Like for instance, here we have a -1 minus -5. So this should be a plus. So we are going to have -1 plus 5, and then we get 4. 7 minus 22, you get a -15. -6 minus 6, this is this -6 minus 6. That's our -12. And then -15 minus 8, -23. 24 minus 44, that's -20. -11 minus 51, that's -62. And then we have a 10 minus -20. You see again, negative times negative, you get a positive sign. So here you'll have 10 plus 20, which is equals to 30. -2, and then minus again and a minus. So here it's plus. So it's a -2 plus 1, which is -1. And then the last element there is negative 10. Yeah, and that's it for today. The other session, we look into multiplication of matrices. But until then, thanks a lot, and please consider subscribing, liking, and comment, and you can even share with people who you think this lesson can be helpful to them. Thank you and bye.